So let's talk about one of the biggest challenges in the world of big data. How do you get hundreds, maybe even thousands, of different computers to all work together like a single, well-oiled machine? It's really the core problem of distributed computing. And you know what? Apache Spark has an incredibly elegant solution. Let's break down exactly how it pulls it off. Think about it for a second. How can one single computer command an entire army of other machines, telling them precisely what to do and when to do it, all while crunching terabytes of data? Well, the answer is actually found in a beautifully simple relationship between two key parts. And to really get it, we're going to use a fantastic analogy. Picture this, a giant symphony orchestra. You've got the conductor up front. They're not playing a single instrument, but they hold the entire musical score. They direct every single section, telling them when to come in, how loud to play, everything. And then you have the musicians, each one an expert, ready to play their part perfectly the moment they're told. That exact relationship, that's the secret to understanding Spark. Okay, so let's make this official. Let's connect that analogy directly to the technology. In our world, the Spark driver is the conductor, and the executors are our virtuoso musicians. To really see how they create this amazing symphony of data processing, we need to dig into these specific roles that each of them plays. First up, let's talk about our conductor, the driver. This is the absolute brains of the operation. It's the central intelligence behind every single Spark job. Now, it doesn't do the heavy lifting itself, but make no mistake, without the driver, nothing happens at all. So the driver's job is a perfect mirror of a conductor's. It takes your code, our musical score, and it creates a master plan. In Spark, this is called a directed acyclic graph, or a DAG. But really, just think of it as the most efficient step-by-step roadmap for getting from your raw data to your final answer. The driver then chops this roadmap into smaller tasks and figures out which musician, which executor, is best for each part. It also serves up that handy Spark web UI so you can watch the whole performance live. And finally, when all the music is played, it's the driver that collects all the results back from the workers. All right, so if the driver is the brains, then the executors, well, they're the brawn. These are the powerful worker processes that are actually out there on the cluster nodes, carrying out the driver's perfectly laid plans. This is where the real work gets done. So what is an executor really? At its heart, it's a dedicated process running on a machine in your cluster. And its entire purpose in life is to do two things, and do them well. Execute the tasks it's given by the driver, and hold on to data in memory to make everything faster. That's it. It's simple, it's powerful, and it's what makes Spark so scalable. And if we dive just a little deeper, the executors are literally where your code comes to life. They're the ones applying all the transformations and running the functions you wrote. And this also shows off their other critical role, data storage. They can cache huge amounts of data right in memory, which is ridiculously fast. But what if they run out of memory? Well, they're smart enough to spill that extra data to disk, and that is an absolutely crucial feature that keeps your whole job from crashing. But here's the thing, the musicians can't just play in a vacuum, right? They have to stay in perfect sync with the conductor. And executors are constantly communicating. The moment they start up, they register with the driver. They send constant little heartbeats back just to say, hey, I'm still here and I'm working. And they report their progress as they finish tasks. They're also the ones handling all the I/O, reading the raw data from places like S3 and writing the final results back out. They do all the heavy lifting. Okay, so we've met the players. We know their roles inside and out. Now for the fun parts. Let's actually watch the performance unfold. We're going to walk through a typical Spark job, step by step, and see how this conversation between the conductor and the orchestra really happens. It all kicks off the moment you submit your code. The driver goes to the cluster manager and says, I need my musicians. Once they're ready, the executors check in with the driver, reporting for duty. Then the driver starts handing out the sheet music. Okay, executor 1, you take this chunk of data. Executor 2, you take that one. The whole time, the executors are sending back progress reports. And as they finish, they send their little piece of the result back to the driver. The driver gathers everything up until the entire job is done. It's just this constant, elegant conversation. Now, understanding this whole relationship isn't just a cool thought experiment. It is the absolute key to tune in your Spark application. If you want the best possible performance, you have to give your conductor and your orchestra the right resources to succeed. And this is where configuration comes in. You can control things like Spark.driver memory, which is basically how much thinking room you give your conductor, and Spark.executor instances, which is as simple as deciding how many musicians you want in your orchestra. I'm telling you, getting these numbers right is the difference between a sluggish, painful performance and a lightning-fast one. So here are some fantastic rules of thumb to get you started. The driver itself is usually pretty lightweight. A couple of cores and a decent chunk of memory is often plenty for it to do all its planning. The executors, though, they're your workhorses. A great starting point is to give each one somewhere between 2 and 5 cores. And for memory, a really common and effective split is giving about 80% to Spark and leaving the other 20% for the machine's operating system to breathe. Look, if you take away just one single thing from all of this, let it be this quote. The driver is the master process that coordinates the entire Spark application. Executors are worker processes that run on cluster nodes to execute tasks and store cache data. That just perfectly captures this powerful partnership. The driver coordinates, the executors execute. Simple as that. At the end of the day, getting this fundamental duo, the conductor and the orchestra, gives you the power to make your data processing faster, more reliable, and just plain better. So the only question left is, now that you know the players, how are you going to tune your orchestra?